Assalamu alaikum warahmatullahi wabarakatuh. Today we'll be talking about the chapter called Telegram. This is the first chapter in our KNX advanced course. As you know, we already studied the Telegram in the basic course. However, today we will be going through specific areas that he wants to talk about. And we'll be focusing on the specific areas that might come in the exam or that we'll need in our practical life. The Telegram chapter is a shorter chapter. That's why I always prefer to start with it. As we know, our protocol is very simple. Let's make our mics muted. Whenever you have a question, you can type it in the chat, or you can send it to me afterward, and then we can discuss in either the same session or the next session, inshallah. The Telegram chapter will have in the exam 3 questions, in theory exam. 3 questions will come, and in our question bank that we'll discuss later, inshallah, after our on-site session, we'll have 5 questions. The Telegram chapter is only online. The advanced course will have some chapters which are totally online, can be totally online, and some chapters that will be have part online and part practical that should be done on site. The chapters that are online we'll do via Zoom as we are doing now, and then we'll discuss later in our training. During the on-site part, we'll discuss it again to have a revision. The chapter which have on-site part and online part, meaning a theory part and the practical part, this will discuss totally. We'll discuss the theory part here online, and then the practical part we'll do it on site in our training center, inshallah Rabbil Alameen. As you know, we always do the practical part on site, not online. Okay, let's start with the Telegram chapter, starting with the duration of the Telegram. Okay, what is the Telegram? Here we are talking about a TB Telegram, by the way, not any Telegram. Telegram meaning the data that will be traveling on the bus. What kind of bus I am talking about here? The TB Telegram, the TB bus, the twisted pair bus. Okay, the duration of the Telegram is from 20 to 40 milliseconds, and this comes in the exam a lot. How to measure or see the length? We check it from the T1 until the acknowledgement. What is the T1? Before I send the telegram, the bus first checks if the device first checks if the bus is free for a T1, then a telegram will be sent. Okay, so this is the T1. So first I'm checking that the bus is not occupied. Okay, then I start my telegram. After I finish my telegram, I wait for something like T2, okay, another milliseconds. Then I should get an acknowledgement. So to say that this telegram duration, the duration is me including the T1, including the telegram itself, including T2, and the acknowledgement as well. This is the measurement of the telegram. A telegram will be minimum 20 milliseconds and maximum 40 milliseconds. Okay, and our bus speed, I don't forget this, is 9,600 bit per second. We discussed this in the theory course, in the basic course, so don't forget it, please. Okay. Okay, good. So once the T1 is done, so that the bus is not occupied, then the telegram can be sent. Wait for T2. Okay. Then I check the acknowledgement. Fine. And all is set here. Okay, good. What is the structure of Telegram? As you can see, a lot of fields. We'll discuss most of the fields today in details. Okay. However, it's a header and useful data. Header is mostly a lot of data, and this is the useful data. This is a part where it contains the useful data, and you can see it's maximum 16 bytes. Okay. Useful data, by the way, is the information I'm sending depending on the action. Meaning what? Let's say today I have a group address connecting a keypad with a light switch, and when I press the keypad, the light switch go on or off. So it's a switching telegram. If you recall the basic code, the switching telegram is 1 bit. It's either on or off. So the useful data that will be sent in this telegram is 1 bit. Okay, 1 bit for what? For switch. Good, good. So let's say this is not a 1 bit. Maybe it's, if you recall our basic course, we had from 1 bit until 14 bytes. 14 bytes was for, if you recall, that was for the text telegram, when I have a text message. Okay. And then from 1 bit to 14 bytes, I have a lot of or useful data in the middle. Okay, we have for relative dimming for bits. Let's say for sensor sending data, it might be 2 bytes, and from 1 bit until 14 bytes, you can get it back from the basic course. Okay, so the grams consist of the sequence of characters, which is a header and the useful data. What is the acknowledgement? Acknowledgement is a 1 byte, okay, that will be sent after the telegram is completely sent, and it has three status. Okay, it's either a busy or a negative acknowledgement, which is NAC, or positive acknowledgement. If positive acknowledgement, then everything is fine. So reception correct. Fine. If negative acknowledgement, meaning that the data was not sent or it was sent in the wrong structure. Okay, so something is wrong with the data. Okay, so this is an incorrect reception. In case of an incorrect reception, then the device, the sending device, will try to send again up to 3 times. If the 3 times sending failed, then I got an error, and maybe the device will not work. So it will not try it again. So it will try up to 3 times in case of negative failure, negative acknowledgement, or not receiving an acknowledgement, okay, or the device is busy. So I send the data, but the device sending me a busy signal saying, I don't have time to do this now, I'm waiting, I'm busy in something else. Maybe the device having a problem, or it's busy in something, okay, different than what I need to do now. Okay, good. So if I receive acknowledgement correct, then it's fine. Everything is good. If negative acknowledgement received, or I don't receive an acknowledgement within the T2 time, then I need to resend again up to 3 times. And if I got a busy signal or a busy acknowledgement, then also I need to send again up to 3 times. Okay. Here he's talking about the structure of the bit formats. We don't need to do that, but we know that a 1 bit, okay, will have 2 values. It's 1 or 0. A 2 bits will have four values. It's 1 0, 0 0 1, 0 0, or 1 1. Okay, and we know that from our study in general. How to convert from decimal to bits and vice versa, it's explained here. However, we do it normally we do it by the calculator now. Okay, so the modern calculator, even the one that you have on your computer, will be able to transfer from it the decimal to binary. Okay, here he's talking now about the other fields, starting with the control field. The control field will have 2 important pieces of information, which the first one is the transmission priority, and is this telegram a new or a repetition? Okay, why repetition? Because if, let's say, I send today a telegram, one device sent a telegram to a group address. The group address has 3 devices. 2 devices said, okay, I received the telegram. And one of them said, no, I did not receive the telegram. Then I will try again to send again to the group address, okay, up to 3 times. In this case, I need to know that those devices that received the telegram and acted already they are not acting again. So they know that it's a repeated telegram, so they don't count it. Okay, but the device that did not receive before, he knows it's a repeated telegram, but for me it's a new, so I can take it as well. Okay, and the priority, and we have 4 priorities as we recall. The default one is a low priority. So by default, all telegrams are sent using the low priority. Okay, and then I have high priority, or an alarm, or a system. System I cannot change. Okay, this is one I cannot change. However, I can change my group objects and objects in the telegram from low to high or alarm. Normally, I don't do that unless I really have a reason for that. Reason like what? I have a central function that I needed to go without any interruption to have a highest priority. I'm doing an alarm system that I now want to give it a higher priority. In this case, yes, I can change that, but normally I don't change that. So the control field will show me, is it a repeated telegram or a new telegram, and the priority of the telegram. Okay. Then I have the individual address. The individual address, as we recall, is the source address is normally an individual address. Okay, and it is 2 bytes, as we can see, 2 bytes. So 4 bits, 4 bits, 8 bits, 2 bytes. Okay, this is how I'm representing it. And as we recall, it's normally area.line.bus device. And this should be unique in our topology. This we learned and we know from the basic course. This is a source address. So now I have a control field. I have a source address. So then I have the target address. The target address is normally an individual address or a group address. Most of the time, it's a group address because this is the one for the operation. Remember, we send an individual address, and then we have a group address of the devices that are going to act based on the device I sent. So if I'm pressing on a keypad, the sending source, the source address is the individual address of the keypad, but the destination address is, or the target address is mostly the group addresses containing the devices that I need them to act based on what I need based on the keypad. So if the keypad should switch three lights from different activators as an example, then I will have in the group address the group objects from the three different activators. Okay, and then the destination address will be the group address. Okay, this we discussed in the basic course. I'm just trying to remind you. And we said also that the group address normally comes with three structure, three-level structure, two-level structure, or free structure. And we said that we normally use the three-level structure and two-level structure in medium to small projects. However, for bigger projects, we use the free structure because it gives me a lot of freedom in describing my group address. In the three-level structure, as we said, that normally what we used to do that the first level, okay, will be for the floor, and the second level or the middle group will be on the function that I need to describe, like heating, like ventilation, like lighting, okay. And then I have here in the third or the group address itself, I have a description of the function that group address is doing, okay. So it's normally target as normally a group address, okay. Here I have, as you can see, it's 2 byte plus 1 bit. This bit will determine is it a group address or individual address, okay. So this bit, okay, will determine is it a group address or individual address, okay. Group, of course, is saying that with one group address, I can address more than one bus device. This number of address I can get. Okay. This is the normal number of group address I can get. Okay. Is 65,535. This is up to from ETS4, by the way. In ETS3, it was less than this. I think it was 32,000 something. It was represented in 8 bits, not 16 bits. Okay. Okay. Good. What else I have? I have the check byte at the end. The check byte is a parity check. Okay, parity check is normally counting the ones and the zeros, okay, and sending a bit saying that the number of ones and zeros should be odd or even. Okay, this way we have not parity or an even parity. Okay, and then I compare this number. Okay, let's say I have in my byte, I have 3 ones, so it should be a not parity. And I send that it's a not parity, so I send in the last bit a 1. Okay, so the bit here saying a 1. Okay, and then when I received my telegram, I found that yes, I have 3 bits as ones, but the parity check is saying it's a 0. So something is different here. It's either one of the data is wrong or the parity check is wrong. In either case, the telegram is not in the right way, not in the right structure. In this way, the telegram is lost. Okay, the telegram might be lost. In this case, I have to say that this telegram is not correct. I can have a resend of the telegram again. Okay, this is all for the telegram chapter. If you have any question, let me know, and I will see you inshallah Rabbil Alameen in the next video. Okay. Salam.